Usually when we think about empty space, we just assume it's exactly that, empty.
Right, just a void.
Yeah, exactly. You look across the room right now, you see the air, you see the distance between you and the wall, or you and the windshield of your car, and your brain automatically registers it as a void. It's like it's the blank canvas where the universe paints all the actual stuff.
The planets, the stars, your coffee cup, all of it.
Right. But so what if that gap, that absolute void of nothingness around you right now, is actually the most complex, rigid, and, well, active thing in the entire universe?
Mm.
What if that empty space is actually a dense, invisible geometric grid that dictates literally everything that happens?
I mean, that is the absolute definition of a paradigm shift. Moving from this idea of a passive void to a highly active, structured medium.
It really is.
Because for over a century, the greatest minds in physics have operated under this one massive assumption that the fundamental nature of reality, at least at the smallest quantum level, is probabilistic.
Right, the whole rolling the dice thing.
Exactly. Standard quantum mechanics tells us that things simply don't have a definitive set state or location until we consciously observe them. But the stack of research we are looking at today for this deep dive completely shatters that assumption. We are getting into a radical new 2026 paper by physicist George James Dukas.
And this introduces what he calls transdimensional unified field theory, right? TDUFT.
That's the one.
Okay, let's unpack this, because the central claim of this paper is just massive. Dukas claims this theory completely solves the double slit experiment. And for anyone who follows physics, you know that is the holy grail.
Oh, absolutely. It's the white whale of modern physics.
Yeah, it's the most famous, just brain-breaking puzzle in the entire history of science. It's the experiment that forced us into that weird probabilistic worldview in the first place. But Dukas isn't solving it by, adding more weird quantum magic or extra dimensions.
No, he's not. He is solving it by completely redefining what empty space actually is.
Which is such a refreshing approach, honestly.
It really is. The argument here is that standard quantum mechanics has been getting the math mostly right for 100 years, sure, but they've been completely misunderstanding why the experiment actually works in physical reality. TDUFT offers this purely deterministic, geometric alternative. It basically argues that the universe is not playing dice. Everything happens for a direct, physical, mechanical reason.
Okay, so before we can dive into this invisible grid, which the paper calls the philatus, by the way, and all the wild, universe-altering mechanics that Dukas proposes, we really have to set the stage for you.
Yeah, we need some context.
Right. If you are listening to this, you might be vaguely familiar with the double slit experiment, but we need to remind ourselves why this original problem has driven physicists completely crazy for over 2 centuries. We have to go all the way back, to 1801.
To Thomas Young.
Yes, Thomas Young.
So Thomas Young was dealing with a very fundamental debate of his time, which was, is light a particle or is it a wave? Isaac Newton had argued strongly that light was made of particles, little corpuscles. Young wanted to test this. So he sets up a rudimentary light source, and he shines it at a barrier. And cut into this barrier are 2 very narrow parallel slits. Just behind that barrier, he places a screen to catch whatever comes through.
It's a beautifully simple setup. If the light is just made of particles, think of them like tiny bullets. Or if we want a more visual analogy, imagine shooting a paintball gun continuously at a wooden fence that has 2 slats missing.
That's a great way to picture it.
Yeah, you would fully expect to see paint on the wall behind the fence in the exact shape of those 2 missing slats. Just 2 bright bands of light directly behind the 2 slits.
Right. That is the logical expectation for physical matter traveling in straight lines. But that is absolutely not what Young saw.
No, it wasn't.
When he looked at the screen, he didn't see 2 bands. He saw a series of alternating bright and dark bands spread out across the entire screen, a sort of barcode pattern. In physics, we call this an interference pattern, and it is the absolute hallmark of wave behavior.
Okay, let me make sure we visualize this clearly for the listener.
Yeah.
If you drop 2 heavy pebbles into a completely still pond at the same time, maybe a few feet apart, they both create these circular ripples traveling outward.
Yes, expanding circles.
And when those 2 sets of ripples crash into each other, really interesting things happen. Where the peak of one ripple meets the peak of another, they combine and build a wave that is twice as high. That's constructive interference. And in Young's experiment, those correspond to the bright bands of light on the screen.
Exactly. And conversely, where the peak of one ripple meets the deep trough of another, they essentially cancel each other out. The water just goes flat. That is destructive interference, which corresponds to the dark, empty bands on the screen where no light seems to land at all.
Right.
So Young demonstrated this perfectly with light, proving that the light waves were passing through both slits simultaneously, interfering with each other on the other side and creating that pattern. It was considered a closed case. Light is a wave, done.
But the case was absolutely not closed. Because, well, physics doesn't like to leave things alone. The 20th century rolls around, our technology gets vastly more sophisticated, and we start revisiting this classic experiment. We decide to do it not just with a continuous beam of light, but with individual discrete chunks of matter.
We use electrons.
Right, electrons. Then we use photons. And the source material today even references these wild experiments done in 1999 at the University of Vienna using C60 molecules.
Ah, the famous buckyball experiment.
Buckyballs, yeah. So Buckminster fullerene, or buckyball, is this massive complex molecule composed of 60 carbon atoms arranged in a spherical shape, kind of resembling a soccer ball.
And compared to an electron, a buckyball is an absolute behemoth. I mean, it is definitively a physical object. You can measure its mass, its structure.
It's a real thing.
Yeah.
So we take these definitive physical objects, these microscopic soccer balls made of carbon, and we start firing them at the two slits. But here's the catch. We don't fire a stream of them, we fire them one by one.
Right, one at a time.
Fire a buckyball. Wait a minute, fire another. Wait. Now they are traveling completely alone. They hit the screen one at a time, landing as localized, single dots. Ping, ping, ping. They aren't smearing across the screen like a wave of water. They're hitting exactly one tiny measurable spot.
Which confirms they are behaving exactly as discrete particles should upon impact.
But here is where the universe seemingly decides to play a massive prank on human logic. If you sit there for hours or days, firing enough of those individual particles one by one, and you track where every single dot lands,
It's mind-boggling.
you step back from the screen, and the dots have slowly clustered together to form that exact same alternating wave interference pattern.
It is entirely counterintuitive.
It makes zero sense. If I am firing a single physical paintball, and it only goes through one gap in the fence, how on earth does it know where to land on the back wall to help build a massive wave pattern over the course of a week? Like, what is it interfering with? It's alone. Standard quantum mechanics, which the paper refers to as SQM, has a very specific, and I would argue very unsettling answer to this.
It does. Standard quantum mechanics relies on the Copenhagen interpretation, which was developed primarily by Niels Bohr and Werner Heisenberg in the 1920s. Their answer to this paradox is that while the particle is in transit between the gun and the screen, it does not actually exist as a solid, localized, physical object.
Wait, it just gives up its physical reality. Like
Yeah.
it just stops being a thing.
In a sense, yeah. Yes, it does. The theory posits that it exists merely as a wave function. Now, this isn't a wave of physical energy like a water ripple. It is a wave of pure mathematical probability. It represents all the possible places the particle could be. According to the Copenhagen interpretation, this wave of probability passes through both slits simultaneously. This is the famous state of superposition.
So the particle is essentially everywhere and nowhere at the same time.
Correct. The probability wave goes through both slits, interferes with itself on the other side, and dictates the odds of where the particle will eventually land. But here is the kicker. The wave only becomes a solid physical particle again when it hits the screen and registers a hit.
Okay, so
The act of hitting the screen forces the universe to make a choice. The vast wave of probabilities suddenly collapses into a single definitive point in space and time.
it's like a person walking up to a building with two doors. And instead of picking a door, they dissolve into a ghost, split in half, float through both doors at the exact same time, bump into themselves in the hallway, and then instantly recombine into a single, solid human being the very second you blink and look at them. I mean, come on. Why is it so philosophically troubling that this collapse happens? Don't standard physicists just accept this today?
Well, they largely accept it because the mathematical formulas derived from this interpretation work flawlessly. You can predict the statistical distribution of the dots perfectly using wave function math, but conceptually. It raises a monumental issue known as the measurement problem. What actually triggers this magical collapse? The standard answer is observation or measurement. But then you have to ask, what counts as an observer?
Right. Does it require a conscious human mind looking at the data?
Does a digital camera count?
Exactly. What if the camera's recording but no human ever looks at the footage?
Or, famously, Erwin Schrödinger's cat. Schrödinger actually proposed his cat thought experiment to mock how absurd this idea of macroscopic superposition was. The measurement problem forces us to ask this huge question. Is the quantum wave function a real physical phenomenon out there in the universe, or is it just a mathematical abstraction, like a statistical tool we invented to hide the fact that we don't know what's actually going on behind the scenes?
And this brings us directly into the crosshairs of George James Dukas and transdimensional unified field theory. Because if the standard explanation relies on this spooky probabilistic math where solid matter doesn't even exist until you force it to by looking at it, TDUFT throws that entire philosophy in the garbage.
Right out the window.
It says, no, the universe is not playing dice, and it absolutely does not care if a human being is looking at it. But to explain how Dukas accounts for the wave pattern, we have to go back to that opening thought exercise about empty space.
Yeah.
We have to completely redefine the stage itself.
Yes. To understand TDUFT, you have to embrace the concept of the free lattice. Dukas argues that the vacuum of space is physically real. It is a geometrically active, highly structured medium. It is not a passive void.
A structured lattice.
Okay.
I want you, the listener, to picture this in your mind right now. Think of the empty space between you and your speakers not as air and not as nothingness, but as an incredibly dense, invisible scaffolding.
The paper defines this scaffolding as being composed of an infinite, contiguous array of what it calls D1 nodes. And these nodes are not just scattered randomly like sand on a beach. They are rigidly locked together in a state of icosahedral symmetry.
Okay, for those of us who aren't playing Dungeons & Dragons every weekend, an icosahedron is a 20-sided, three-dimensional shape. Picture a classic 20-sided die. Now picture an infinite invisible grid made entirely of these 20-sided shapes, packed tightly together, filling every millimeter of the universe, extending out to the very edges of the cosmos.
The mathematical geometry of this structural packing is governed by phi, the golden ratio. That's approximately 1.618.
The golden ratio is everywhere, though. It's the spiral we see in sunflower seed heads, the curve of a nautilus shell, the swirl of a hurricane, the shape of massive spiral galaxies.
It is ubiquitous
Yeah.
in nature, yeah. And the paper makes a really compelling argument that this icosahedral structure governed by the golden ratio isn't just an arbitrary aesthetic choice by the universe. Mathematically speaking, it is the most efficient way to pack information and maintain long-range order while simultaneously allowing for local rotational symmetry. It is the ultimate stable geometric substrate.
Hold on. I'm going to push back on this geometry for a second.
Yeah.
Because if you've ever actually tried to stack a bunch of 20-sided dice together on a table, you quickly realize you can't. They don't tile perfectly in three-dimensional space like cubes do. If you pack a bunch of icosahedrons together, you are going to get little angular gaps. It's geometrically impossible to fill space perfectly with them.
You hit the nail on the head, and that geometric impossibility is actually the secret engine of this entire theory.
Wait, really?
Yes. Dukas doesn't ignore that gap. He utilizes it. Because icosahedrons cannot perfectly tile Euclidean space without leaving gaps, forcing them into an infinite continuous lattice creates inherent microscopic structural tension. The grid is constantly frustrated. The space itself has to dynamically flex or warp infinitesimally to maintain its structure. This means the vacuum is not a dead, rigid crystal. It is a tensegrity structure, a web of constant vibrating tension. That tension is what allows it to transmit energy.
Oh, wow. That is brilliant. The imperfection is the feature, not the bug.
Exactly.
Okay, so we have this infinitely tense grid of 20-sided nodes. What do these nodes actually do? The paper states that each individual node carries two fundamental properties, density and torsion.
Let's define those carefully. Density, which the paper denotes with the symbol phi, is that specific node's capacity to guide, concentrate, or resist energy. You can think of it as how thick or viscous that specific microscopic point in the vacuum is. Torsion, on the other hand, is its helical rotational interaction. When energy passes through a node, how does the node spin or twist in response?
So this invisible grid actually has physical texture. It has friction, it has spin.
Yes, it does. And the paper lays out a whole hierarchy of dimensional levels, or D operators, to categorize how things interact within this lattice.
Walk us through these D operators. Who are the players on this geometric stage?
First, at the foundation, you have the D1 level. These are the lattice nodes we've just been discussing. This is the static fundamental geometric scaffold of the vacuum itself. Next, we move up to D2. These are helical torsion wavefronts.
Okay.
When a burst of energy is released, it doesn't just jump magically from point A to point B. It moves through the D1 lattice by twisting and vibrating those nodes. The energy propagates as a twisting, corkscrew-like D2 wave. This is how photons, or light, and other coherent disturbances actually travel across space.
Let me make sure I'm wrapping my head around this. If the D1 nodes are the train tracks, the D2 torsion wave is the physical vibration you feel in the steel rails when a train is approaching.
A very apt metaphor, yeah. Then we reach the crucial level for our discussion. D3. These are localized excitations. In plain English, D3 is what we call physical matter.
Okay.
An electron, a carbon atom, a buckyball, a human being. In standard physics, we think of a particle as a solid little billiard ball floating in an empty void. In TDUFT, a particle is actually a localized region where the density and torsion of the lattice itself are heavily elevated, bound together, and stabilized. The matter literally is a knot in the lattice.
A knot in the vacuum. That's wild.
And finally, the paper outlines D4 and beyond, which govern massive, higher-order macroscopic and cosmological structures, like how these localized D3 knots aggregate to form planets, stars, and the gravity wells we observe in the macro-universe.
Let me throw another piece of pushback at you, because this is where my brain starts flashing warning signs. If empty space is actually this incredibly dense icosahedral grid full of tension and friction and torsion, why doesn't the Earth slow down as it orbits the sun? Wouldn't this massive physical lattice create unbelievable cosmic drag on planets?
It is the most natural question to ask, and it goes back to understanding the difference between the D operators. The Earth, which is a massive collection of D3 excitations, is not a solid object crashing through a rigid grid, like a bowling ball crashing through a dense forest. The Earth is a localized, moving pattern of elevated energy within the grid.
Wait, say that again?
Think of a wave moving across the ocean. The wave can travel thousands of miles, but the actual water molecules aren't traveling thousands of miles. They are just bobbing up and down, passing the energy along. The D3 excitation moves through the D1 lattice smoothly because it is the lattice shifting its state. There is no drag because the medium is propagating the state, not resisting a foreign object.
Ah, it's like a message moving across a digital billboard. The lights aren't sliding across the plastic frame. The pattern of illumination is just transferring from bulb to bulb.
Exactly that. The information moves smoothly without the physical substrate needing to be displaced.
I love that. Okay, I think I have a working analogy for this whole system. It's like the universe is a massive, incredibly complex, three-dimensional pinball machine. The D1 nodes are the rubber bumpers scattered everywhere. The D2 wavefront is the physical vibration traveling through the rubber bumpers when something hits them, and the D3 particle is the pinball itself, rolling through the system.
And notice the crucial difference your analogy highlights compared to standard quantum mechanics. In the Copenhagen interpretation, the pinball and the vibration are somehow magically the same entity, shape-shifting back and forth. TDUFT separates them entirely. The wave is the wave. The particle is the particle.
Yes, and that exact separation is the golden key to how Dukas solves the double slit experiment. So let's reset our laboratory. We've built the phi lattice pinball machine. We understand the bumpers in the pinball. Now let's fire a particle through those two narrow slits and see how TDUFT explains the barcode interference pattern without ever once using the word superposition or claiming the particle becomes a ghost.
To visualize this, we really need to look closely at Appendix A in the source material. Dukas provided a deeply detailed conceptual diagram that maps out exactly what happens mechanically in the lattice.
I am looking at this diagram right now, and I will be the eyes for anyone listening. On the far left side of the image, we have a green box labeled Source D3 Emitter. That's our particle gun. To the right of that, maybe a few inches away in our imaginary scale, we have our solid barrier with two narrow gaps, Slit 1 and Slit 2.
Right.
And way over on the far right is the detection screen. The entire space between the barrier and the screen is labeled the lattice interference zone, and the diagram fills this space with thousands of tiny dots, which represent those 20-sided D1 nodes we just spent time exploring.
Now, here's the absolute divergence from standard theory. When that D3 emitter fires, standard physics says it shoots out one thing, a wave function. TDUFT states that the physical machinery of the emitter physically impacts the vacuum and emits two distinct things simultaneously.
Wait, two things.
Yes. The source fires the D3 localized particle or payload, the pinball, but it also emits a massive D2 helical wavefront. It creates a huge ripple in the phi lattice that spreads out, surrounding and actually preceding the particle.
So it pushes a wave out ahead of itself.
Exactly. This is where we apply a physical, lattice-based version of Huygens' principle. As this massive D2 wavefront expands outward from the gun, it hits the barrier. The solid wall blocks most of it. But the portions of the wavefront that align with the two open slits pass right through. The D1 nodes located exactly at the openings of those slits are violently agitated by the wave.
Okay, I see where this is going.
They act as secondary emitters. They take that wave energy and re-radiate it, sending out two new overlapping D2 torsion waves into the phylatus on the far side of the barrier.
So mechanically, it's identical to the water waves coming through two gaps in a breakwater. And the diagram shows exactly what happens when these two new sets of invisible vacuum ripples overlap in the interference zone. We see regions of constructive interference, which the author has marked with purple nodes. This is where the twisting torsion wave from slit 1 and the wave from slit 2 are perfectly in phase. Their peaks align. They combine, and the local density and tension of the vacuum physically amplify. The grid literally gets thicker and more highly energized in those specific purple bands.
And wedged directly between those purple bands, we see bands of green nodes. These represent regions of destructive interference. The wave from slit 1 is at a peak, while the wave from slit 2 is at a trough. They twist against each other and cancel out, leaving the vacuum in those gray zones relatively relaxed and low density.
So it's making a pattern in the vacuum itself.
Yes. What this process creates is a stable, purely physical landscape of invisible peaks and valleys in the vacuum. The paper terms this the phi gradient field. It's a real geographic, topographic map of high and low density.
Okay, so the invisible D2 torsion waves have raced ahead, gone through both slits, and churned up the vacuum into this topographic map of peaks and valleys. But what about the physical particle, the pinball? In the diagram, there is a distinct, thick, amber-dashed line tracing from the source gun through the barrier all the way to a bright spot on the screen. And here is the crucial reality-grounding insight of this entire paper. The particle does not go through both slits.
Emphatically no. The localized D3 excitation, the solid matter, passes through one slit and one slit only. There is no superposition, there is no splitting in half. It is a discrete physical entity taking a singular, discrete path.
It just randomly picks a slit based on its initial trajectory and flies through it. So if the buckyball only goes through slit 1, why does it eventually land on the screen in a location that builds a wave pattern? If it's a solid object, should it just fly straight and hit directly behind slit 1?
It would fly straight if the space behind the slit were truly empty, but it isn't. As soon as the particle exits the slit, it enters that invisible phi gradient field. The landscape of peaks and valleys created fractions of a nanosecond earlier by the D2 wavefronts. The paper mathematically demonstrates that a D3 excitation is deterministically pushed along the steepest descent path of this density gradient.
So it physically surfs the lattice.
That is exactly what it does. Just as a heavy ball rolling across a warped trampoline will follow the curves of the fabric, the particle is mechanically drawn toward the regions of highest density, the purple nodes of constructive interference, and it is repelled by the relaxed troughs. It is following the path of most intense geometric tension.
The diagram beautifully illustrates this. It labels these high-density destination points on the screen. The particle rides the invisible gradient directly toward the bright fringes, which are labeled M-0 in the center, and M plus or minus 1 and plus or minus 2 on the sides. Let me synthesize this with a new analogy. The D2 torsion wave is like a massive snowplow.
Okay, I like that.
It drives out ahead of the actual particle, hits the barrier, splits into two smaller snow plows that go through both slits, and they plow a very specific, overlapping ridged pattern of clear paths and massive snowbanks into the heavy snow of the phylatus. The D3 particle is just a car following closely behind. The car only drives through one slit, but once it gets through, its steering wheel is locked, and it is forced to follow the deep grooves carved by the snowplows. It ends up at a specific destination on the screen because the road was warped before it got there.
That is a phenomenal, visceral way to understand Ducas's mechanics. The wave and the particle are distinct entities performing different functions. The D2 wavefront explores the global geometry of the slits and alters the physical state of the vacuum. The D3 particle is a local passenger simply following the path of highest density created by that exploration. The car never went down two roads at once, the snowplow did.
The elegance of that is breathtaking. There is no duality. The particle never has an identity crisis. It's always a particle. The wave is always a wave. No magical collapse required. But, hold on. This brings up the giant glaring elephant in the room. If we are throwing out standard quantum mechanics, we have to address its strongest defense mechanism, the which path paradox.
Yes. The paradox that has fueled countless debates about the nature of consciousness and reality.
Right. Because the whole reason Niels Bohr and standard physicists insisted that the particle must be a ghost going through both slits is because of what happens when we try to catch it in the act. In a standard lab, if you set up the double slit experiment, but you place a tiny sensor or a camera right next to slit 1 just to peek and say, aha, I caught the buckyball going through slit 1, The universe punishes you.
It does indeed.
The beautiful interference pattern on the back screen instantly vanishes. It collapses into two boring clumps of dots, just like bullets hitting a wall. Standard quantum mechanics smugly says, "See, the act of you looking forced the wave function to collapse back into a solid particle before it can go through both slits and interfere with itself." If Dukas is right, and the particle is always solid and only ever goes through one slit anyway, why does putting a camera next to the slit destroy the wave pattern on the screen?
To understand TDUFT's answer to this, we have to completely demystify the mystical concept of measurement. Standard quantum mechanics treats a detector as an abstract philosophical concept, an observer that somehow imparts knowledge into the system. Dukas and TDUFT treat a detector as what it actually is in physical reality, a bulky physical object occupying physical space.
Right. A camera isn't a magical consciousness ray. It is made of billions of atoms of plastic and glass. It has a battery, it runs electrical current, it generates a localized electromagnetic field. It is a hunk of metal sitting in the vacuum.
And in TDUFT, inserting a hunk of highly energized matter into the philatus introduces a massive physical perturbation into the local geometry of the vacuum. The paper represents this mathematically with the operator M. When you place a detector near slit 1, you are physically churning up and muddying the waters of the vacuum at that specific critical location.
Going back to our analogy, you aren't just watching the road, you are dropping a giant boulder right in the middle of our snowplow's path.
Yes. The physical mass and energy of the detector rigidly couple to the D1 lattice nodes around it. This massive disturbance ruins the delicate structural coherence of the D2 torsion wavefront as it tries to exit that specific slit. Remember, to build those nice, neat peaks and valleys, the phi gradient that guides the particle, the invisible wave coming from slit 1 and the wave from slit 2 have to be perfectly in sync. They have to be phase coherent.
So, the bulky camera violently scrambles the wave coming out of slit 1.
Precisely. The math in the paper is very clear on this threshold. It states that if the phase difference, denoted as delta theta, between the two waves exceeds the lattice's natural coherence threshold, which it calls the theta c, the waves can no longer constructively interfere. The delicate overlapping geometry is just shattered. The phi gradient vanishes completely, dissolving back into flat, randomized baseline noise.
And if there are no deep snowplow grooves to follow,
The D3 particle just flies straight. It exits the slit, finds no gradient to surf, and continues on a simple linear Newtonian trajectory, striking the screen directly behind the slit, exactly as a bullet would. The interference pattern disappears entirely.
So let me zoom out and ask, what does this actually mean for us philosophically? I'll tell you what it means for me. It means human consciousness isn't magically controlling the fabric of reality. The universe doesn't care if a scientist in a white lab coat is looking at a computer screen. It doesn't care if a camera is recording data. It is entirely, brutally, beautifully mechanical. Putting a bulky machine next to the slit just physically stirred up the lattice so badly that the delicate invisible wave couldn't form properly. We, clumsy humans, just broke the machine we were trying to measure.
It is a deeply grounded, substrate-based explanation. It replaces the mystical, almost solipsistic concept of wave function collapse triggered by an observer with a simple mechanical reality. Physical things disturb other physical things. When you stick a thermometer in a cup of hot water, the cold glass of the thermometer slightly lowers the temperature of the water. You altered what you were measuring. TDUFT applies that same undeniable logic to the quantum vacuum.
Okay, I am fully on board with the snowplow, the car, and the boulder ruining the road. The logic tracks perfectly. But standard quantum mechanics has one more terrifying trick up its sleeve to defend its weirdness. And honestly, this is the stuff that keeps me up at night because it defies all linear logic. I'm talking about the experiments where physicists try to trick the universe, where we let the particle go through the slits freely and then we turn the camera on. Wheeler's delayed choice experiment.
Ah, yes. Proposed by John Archibald Wheeler in 1978 and executed in various forms since. This is the experiment where standard quantum mechanics seems to suggest that time travel or retrocausality is a real, functional aspect of our universe.
If you are listening to this right now and your brain is melting because it sounds like we're about to justify time travel, you are not alone. Let me set up Wheeler's experiment so we can understand the sheer lunacy of the standard explanation. In a delayed choice experiment, you fed up the classic double-slit barrier, but you position your cameras or detectors far behind the barrier, deep in the interference zone, and you hook their power switch up to an ultra-fast random number generator. The particle gun fires. The buckyball passes through the barrier. Now, while the particle is in mid-flight toward the back screen, The random number generator decides whether to turn the cameras on or leave them off.
It decides whether to measure which path information or to allow the interference pattern to form naturally, but it makes that definitive choice after the particle has supposedly already committed to its path through the slits.
Right. The particle's already passed the door, and the results in the lab are staggering. If the camera turns on at the last possible nanosecond, the particle hits the screen like a solid bullet, no interference pattern. If the random number generator keeps the camera off, it lands as part of a beautiful wave pattern. According to standard quantum mechanics, our present choice to turn the camera on actually reaches backward in time to tell the particle, hey, I'm watching you now, you need to go back and only go through one slit as a solid particle, not both slits as a wave. Retrocausality. The future is rewriting the past state of the particle. It breaks all linear causality. How in the world does TDUFT cancel time travel and solve this?
It cancels it by reminding us of the physical reality and endurance of the philatus. The time travel paradox only exists if you believe the guiding wave is a fleeting, momentary event, a ghost that disappears the moment the particle clears the slits. TDUFT asserts that the D2 wavefront does not just poof out of existence. It creates a sustained, ongoing structural disturbance throughout the entire lattice between the barrier and the screen.
Wait, so it's not a single passing ripple. It's a standing vibration, filling the whole room for the duration of the flight.
Exactly. The phi gradient field, encoding the complex geometry of the interference pattern, is physically present everywhere in that space, continuously maintaining the tracks while the D3 particle is traveling. So, when the random number generator flips the switch and turns the bulky detector on at the last microsecond, you are not altering the past. You are physically modifying the boundary conditions of the field spatially in the present moment.
Okay, let's slow this down and walk through it step by step. I flip the switch. The detector powers up and surges with electricity. What physically happens in the lattice in that exact microsecond?
The sudden introduction of energy and physical perturbation from the detector creates a violent disruption in the nearby lattice nodes. This disruption ripples backward through the lattice toward the slits. But, and this is the crucial distinction, it does not travel backward in time. It travels backward in space, moving through the tense geometry of the lattice at the speed of torsion wave transmission.
Just like if I drop a heavy rock into the far end of a pond, the chaotic ripples move outward from the rock and violently disrupt the smooth ripples coming from the other side.
Yes. The Dukas paper likens it to acoustic vibrations traveling through a dense crystal. The chaotic disruption ripples outward from the newly activated detector and instantly destroys the delicate structural coherence of the phi gradient field before the slow-moving D3 particle arrives at the screen. The smooth road is destroyed by an earthquake while the car is still driving on it.
Whoa.
The particle, which is deterministically following whatever density gradient exists at the exact moment it traverses a specific region, suddenly finds the high-density path gone. The vacuum has flattened into chaotic noise. Without the gradient to guide it, the particle defaults to a straight line. It flies straight and hits the screen like a bullet. It is a completely causal, forward-moving timeline. No retrocausality, no time travel required.
Oh, man. The relief I feel hearing that is immense. The future isn't changing the past. The detector's just causing a structural earthquake that ruins the road ahead of the car. It is so perfectly logical. But wait, we have to tackle the final boss of quantum weirdness. What about the quantum eraser? Because this is the 1982 Scully and Joule experiment, where physicists realized they could basically hit Control-Z on the universe and undo a measurement.
The quantum eraser is perhaps the most conceptually agonizing experiment for standard mechanics to explain without invoking literal parallel universes splitting and merging.
Right.
In this setup, you obtain the which path information, you turn the detector on, you record which slit the particle went through, and store it on a hard drive. As we now expect, the interference pattern disappears on the screen. But then, before any human being looks at the final data on the screen, you scramble, encrypt, or completely erase that which path data from the hard drive.
You highlight the file and hit delete. You destroy the knowledge?
Essentially, yes. And miraculously, when you finally look at the screen data, the wave interference pattern has returned. Standard mechanics argues that erasing the information in our macroscopic world physically disentangles the particle in the past and restores the collapsed wave function. It relies heavily on elevating human information to a fundamental physical force that governs reality.
But TDUFT doesn't care about our hard drives. It doesn't care about human information. It only cares about physical geometry. So how does Dukas explain the eraser mechanically? I'm trying to piece this together. If turning a detector on introduces a physical perturbation, dropping the boulder on the road that destroys the gradient, does erasing the data just mean we are lifting the boulder back up, re-smoothing the road?
You are tracking the logic perfectly. In a real-world lab, erasing the data isn't just pressing a software key, it involves physically altering the experimental apparatus. You use beam splitters, you change the polarization filters, you alter the optical path to scramble the signal. When the apparatus is adjusted to erase the data, it physically stops heavily perturbing the delicate phi lattice in the interference zone.
The boulder is lifted off the road.
Precisely. The lattice is an incredibly elastic, resilient geometric medium. Once the severe physical perturbation is removed, the lattice relaxes back to its natural, undisturbed, coherent state. The D2 torsion wavefronts coming from the slits reestablish their phase coherence, the phi gradient reform.
And the snowplow starts making clear paths again for the next particles.
Exactly. But there's a vital, often overlooked detail here regarding how these experiments are actually conducted. The paper clarifies how post-selection filtering works. When you look at the final screen, the interference pattern doesn't just magically pop back into existence for the particles that flew through while the detector was active and scrambling the lattice.
Oh, it doesn't.
No. When researchers do the quantum eraser experiment, they have to look at the massive pile of data and find coincidences. They use timestamps to filter the data. They only look at the data points that correspond to the exact fractional moments. The erasure mechanism was fully active and the lattice was calm.
Ah, so they throwing out the bad data where the lattice was scrambled.
Yes.
Well,
In TDUFT, this isn't parallel universes colliding or timelines healing themselves. It's just temporal filtering of a mechanical process. The particles that transited the space while the detector was violently perturbing the lattice did not surf a gradient, and they landed randomly. The particles that flew through exactly when the apparatus was in erase mode, meaning the lattice had recovered its geometric coherence, did surf the gradient and formed a wave pattern. You are simply filtering your data set based on the physical state of the vacuum at the precise time of transit.
that brings such a profound sigh of relief. We've taken all the magic, all the spooky action at a distance, all the time-traveling retrocausality, and we've reduced it to fluid dynamics and structural tension in a 20-sided geometric pinball machine. It's conceptually brilliant. But as we know in physics, a beautiful concept is worth absolutely nothing if the rigorous math doesn't back it up. A theory lives and dies by its equations.
And this brings us to the underlying mathematical framework driving this deterministic universe. If this invisible geometry actually dictates reality at the quantum level, it must control other universal limits, right?
Exactly. There's an equation in the source material we were given, and just looking at it makes my eyes cross. It's titled the speed of light equation. And usually in standard physics textbooks, the speed of light in a vacuum sea is just written as a flat number. 299,792,458 meters per second. It's a fundamental constant. It just is. We accept it. But TDUFT presents a massive, complex formula defining exactly why the speed of light is locked at that specific number. Does this geometry explain the cosmic speed limit?
It absolutely does. What's fascinating here is that Dukas derives the exact speed of light directly from the geometric transmission parameters of the phi lattice itself. The equation, denoted as C of ones, is not an arbitrary constant pulled from thin air. Let's break down its components conceptually. The equation begins heavily reliant on the golden ratio, phi, in various inverted geometric forms, specifically 2 plus phi to the negative 1 plus phi to the negative 2.
So the speed at which light travels is literally dictated by the icosahedral 20-sided geometry of the vacuum. Light can only move as fast as the lattice can twist to pass it along.
Yes. The structure defines the maximum speed of the torsion wave. The equation also includes an infinite harmonic series, specifically subtracting the summation of phi to the negative n plus phi to the negative 2n.
What does subtracting an infinite series represent mechanically, like in the physical world?
Think of it as energy friction or dissipation across dimensional scales. As a pulse of energy travels through an infinite web of nodes, a tiny fraction of that energy bleeds off or resonates into smaller and smaller harmonic frequencies. The subtraction accounts for the physical resistance of the tensegrity structure.
Oh, I see. And then there's this massive fraction block attached to the end of the equation.
That is a continued fraction regulation, utilizing a function called psi of ones.
Okay, you're going to have to explain that to me like I'm 5.
Yeah.
What is a continued fraction regulation, and what does it physically do in the vacuum?
In mathematics, an infinite series can sometimes spiral out of control and diverge to infinity. In physical reality, energy doesn't do that. A continued fraction acts as a mathematical bound. Physically, think of it as a heavy-duty shock absorber in a car suspension. If you hit a bump, the spring wants to bounce up and down forever, eventually tearing the car apart. The shock absorber regulates that energy, dampening it, stopping the bounce from magnifying infinitely, and anchoring the suspension to a finite, stable state. The psi of 1's function is the geometric shock absorber of the vacuum. It prevents the energy transmission from accelerating to infinity, locking it down to exactly 299,792,458 meters per second.
That is incredible. What this formula proves, at least within the context of the paper, is that TDUFT is truly a unified theory. The exact same phi geometry that dictates how an invisible torsion wave builds an interference pattern to guide a buckyball also dictates the absolute maximum speed limit of the universe.
Yeah.
The vacuum geometry is the fundamental reality connecting everything. But this brings me to a massive philosophical pushback.
Okay, let's hear it.
If the speed of light is mechanically locked by a grid, and if every single particle moving through a double slit is just a car following a rigidly defined topographic map created by a snowplow, then true randomness doesn't exist. If we had a computer powerful enough to know the exact geometric tension of every node and the exact starting angle of the buckyball when it left the gun, we could predict exactly where it would land on the screen every single time. There is no probability.
The paper explicitly agrees with that conclusion. TDUFT asserts what we call epistemic limitation. The quantum world only looks random and probabilistic to us because we are clumsy, giant observers. We simply do not have instruments precise enough to measure the exact microscopic starting position, the exact initial topological conditions of the D3 excitation within the phi lattice.
So we are just blindly throwing handfuls of pinballs into a pitch-black machine and acting surprised when we can't guess exactly where they end up, so we invent probability math to cover up our ignorance.
Exactly. The distribution of dots on the screen isn't a fundamental wave of magical probability collapsing. It is just a classical statistical distribution of highly complex deterministic trajectories. If you roll a physical die on a casino table, the outcome isn't fundamentally random. It's determined by the angle of your hand, the force of the throw, the friction of the felt, the air density. We just call it random because we as humans cannot mentally track all those variables in real time. TDUFT says the quantum realm is exactly the same.
This sounds exactly like what Albert Einstein argued for his entire life.
Yeah.
He famously fought Niels Bohr on this, stating, "God does not play dice with the universe." Einstein despised the probabilistic, blurry nature of quantum mechanics and kept insisting there must be hidden variables, underlying mechanical gears turning behind the scenes that our microscopes just couldn't see yet.
Einstein's intuition is entirely vindicated by Ducas's TDUFT. But instead of abstract mathematical hidden variables, the hidden variable in TDUFT is intensely physical. It is the exact geographic spatial starting coordinate of the particle within the complex tense geometry of the vacuum.
Okay, I am sold on the narrative. It's elegant, it cures the headache of time travel, and it honors Einstein. But we need to put it to the test. A scientific theory isn't a theory until it can be proven wrong. If TDUFT and standard quantum mechanics give us the exact same barcode fringe pattern on the screen in a normal lab, and they both predict the same outcome for the eraser experiment, how do we prove Ducas is actually right? How do we prove the icosahedral phi lattice is actually physically there?
A vital question. Ducas outlines 3 specific testable predictions where TDUFT will mathematically diverge from standard quantum mechanics. These are experiments physicists can build tomorrow to prove if the lattice is real. First, they propose testing the decoherence distance.
Explain that.
If the vacuum is a real physical medium, like water or a tense crystal, its ability to maintain a coherent wave must have a physical friction limit. A ripple in a pond eventually dies out. If you scale up the physical size of the double slit apparatus, making the distances between the slits and the screen vastly larger, maybe kilometers long, standard quantum mechanics says the probabilistic math should hold perfectly regardless of distance. The wave function doesn't experience friction.
Right.
TDUFT, however, predicts that over vast distances, the natural harmonic friction of the D1 lattice will cause the D2 torsion waves to lose energy. The phi gradient will naturally degrade in a very specific geometry-dependent way, and the interference pattern will blur out.
Yeah.
Because a physical wave eventually loses steam, no matter how perfect the medium is. You can't ring a bell and expect it to vibrate forever. Okay, that's a highly testable physical limit. What's the second proof? Finite propagation time. Standard quantum mechanics often relies on instantaneous action, what Einstein mocked as spooky action at a distance. When the wave function collapses, standard theory says it collapses everywhere in the universe simultaneously. 0 time elapsed. But in TDUFT, the lattice isn't spooky. It obeys the speed limit. When a bulky detector powers on and perturbs the lattice, that chaotic structural ripple takes actual time to travel outward, dictated by the speed of torsion wave transmission.
So if we have ultra-high-speed coincidence measurements in the lab,
We should be able to clock it. If we place the detector far enough away and turn it on, we should be able to measure the tiny, infinitesimal delay it takes for the disruption to physically travel from the detector and ruin the gradient at the slits. We should literally be able to catch the universe in the act of mechanically updating the lattice.
that is a phenomenal experiment waiting to happen, catching the earthquake as it travels. And the third test.
The third is purely mathematical geometry. Phi-indexed fringe deviations. The standard formula used for 100 years to calculate the spacing between the bright bands on the screen uses basic whole integers mm1, mu2, mu3, and so on. It assumes a flat Euclidean reality. TDUFT, however, indexes these peak positions using multiples of phi, the golden ratio, reflecting the 20-sided icosahedral symmetry of the lattice.
Because the interference peaks are forming along the rigid angular lines of a 20-sided geometric grid, not a perfect smooth square grid.
Exactly. Now, near the dead center of the screen, integers and multiples of phi align very closely, which is why standard math has worked so well for so long. The error is microscopic. But at super high fringe orders, way, way out on the far extreme edges of the interference pattern, the two mathematical formulas diverge significantly. TDUFT predicts that if we use high-resolution electron diffraction and look at the extreme fringes, we will spot tiny, measurable deviations where the light lands slightly off from the classic integer formula, but exactly where the phi ratio predicts.
Wow. So it's not just a philosophical interpretation to make us feel better about reality. It has actual, falsifiable, physical stakes. As we wrap up this deep dive, let's take a breath and look at the massive paradigm shift we've explored today. For 100 years, quantum mechanics has told us that reality at its core is a blurry smear of probability, that matter only decides to exist, to take a definitive shape, when we humans deign to look at it. George James Dukas and transdimensional unified field theory take all that magic, all that spooky guesswork, all the time-traveling paradoxes, and replace them with a beautiful, invisible, geometric architecture. Geometry prevails. The vacuum is a densely packed lattice. The energy wave twists through it, and the solid particle deterministically follows its physical guidance.
It is a profound return to physical mechanism. It restores cause and effect to the throne of physics.
I want you, listening right now, to just stop for a second and look around the room you are in. Look at the empty space between your hands. According to this theory, you aren't looking at nothing. You are looking at an infinitely dense, perfectly packed, vibrating grid of icosahedral nodes, constantly frustrated, constantly tense, all governed by the golden ratio, quietly waiting to guide energy and matter through the universe.
And if that concept isn't mind-bending enough for one sitting, there is one final, incredibly provocative Easter egg hidden deep in the reference section of the Dukas paper. It's a passing citation to another forthcoming paper titled The Free Will Master Equation.
Oh man, I saw that in the footnotes.
It forces a terrifying but necessary logical leap. If our entire universe is a deterministic lattice, if every single physical particle is just an excitation surfing the steepest gradient based entirely on its starting position and the geometry around it, what does that mean for the biology in our heads? What does it mean for the electrical signals firing across the synapses in our brains right now?
The paper subtly hints that human consciousness isn't magical either. It describes what it calls D3 consciousness excitations, interacting with this exact same phi gradient.
It raises the ultimate philosophical question of human existence. Are our complex thoughts, our deep emotional choices, our very sensation of consciousness merely localized geometric disturbances, deterministically surfing a golden ratio of the vacuum? Is free will just an incredibly convincing illusion caused by our brain's inability to calculate the infinite geometry of the phi lattice inside our own minds?
We're just pinballs trying to pretend we are driving the machine, something heavy to ponder the next time you find yourself staring into empty space.
The stage may be set, but perhaps we are both the actors and the floorboards.
Until next time.